All right. Is everybody okay with problem number 1? You rolled an 8-sided die, which is weird to think about, 8-sided, but I guess it could exist. With numbers 1 through 8, find each. Probability of rolling an even number, so you have to go 2, 4, 6, 8. So that's 4 of the numbers. 4 out of 8 outcomes. It's 4 out of 8, or 1/2. Probability of rolling a number less than 7. So you're talking about 1, 2, 3, 4, 5, and 6. So that's 6 out of 8, which would be 3/4. Don't worry about doing the sample space drawings. I mean, it is a valuable tool sometimes, but for the most part, just realize that you could draw it if you needed more clarification, but it's not going to be asked of you to do. All right, so you said you wanted the or. Okay, so let's take a look at number 2. And let's do the and first. Probability of greater than 2 and heads. Okay, so it's a 6-sided die. So greater than 2 is 3, 4, 5, 6. So you have a 4 and 6 chance of rolling greater than a 2. Greater than 2. So 3, 4, 5, 6. Yeah, I did it right. And a heads. A heads is 2 outcomes, so times 1/2. So that's going to give me 4 out of 12. You could leave it like that, or you could reduce it to give you 1/3. But then we want to talk about the or. So this was the and. Let's do the same thing, but change this. And this is going to be a lot more outcomes. Okay? This is where you have to be sure you're not double counting events. So basically, if you looked at rolling the dice, if you made your grid, you can sometimes see this: heads 1, heads 2, heads 3, heads 4, heads 5, heads 6, tails 1, tails 2, tails 3, tails 4, tails 5, tails 6. Okay. So you want to probability of rolling greater than 2 is all of these events. That's the greater than 2. That takes care of that. Or a heads. Okay? And I'm going to kind of underline that. The underlined part, we don't want to double count. Okay? So there are 2 events on our sheet that are not above 2 or heads. So there are 10 events that are taking place. I don't want to double count. A lot of times when I say double count, people will say, oh, I have these 8 events and then all of these heads, which are these 6 events. Don't double count. This is heads. So heads and above 2 falls part of the arrangement. And there's 12 outcomes. If you wanted to, you could reduce this to 5 out of 6. Okay, does that help you on that kind of or? So sometimes this might be helpful because if you see it, you're not going to double count it. Does that make sense? But does that make sense about the double counting? Okay. And it's a real easy error that people forget about with the double counting, especially when you start dealing with a deck of cards, because in the world of probability, if you ever get something that is a fraction and that fraction is a larger number than 1, you know you did it wrong. But sometimes in a deck of cards, because you have 52 outcomes, sometimes it's easy to double count and you're like, okay, well, I have a fraction that's a smaller value than 1, so it must be right. So just be cautious. And then you roll 2 dice. So the dice one, I think, kind of, if you draw the number grid out, it's easier to see because you can start counting. Oops, blue. 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. And then 7, 8, 9, 10, 11, 12. Okay. First off, I know I've just been generating this, but does everyone understand how the blue numbers are happening? Basically, I go 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5, 2 plus 1, same thing, 3 plus 3, 6, 4 plus 5, 9, 5 plus 6, 11, so on and so forth. Okay. So I think excuse me. I think I can do this. So letter B we'll do in red. Probability of rolling a sum of 4 or 8. Okay. So what you're going to do is I have a 4 and I have the 8s. Okay. So that's 1, 2, 3, 4, 5, 6. Wait. 1, 2, 3, 4, 5, 6, 7, 8. So there happens to be 5 of these outcomes. Okay. I can roll a 4 or an 8. There's 5 outcomes. There's 36 total outcomes that take place. Or wait. I just goofed up. I'm so sorry. I have 8 total outcomes. I have 3 4s and I have 5 8s. I have 30 out of 36. Okay, if you wanted to, you could reduce this to 2 9ths. You don't have to. When you do letter C, probability of rolling less than 9. Okay, where this takes place is I could go count up all the events that are less than 9, or I could count up the events that are bigger than 9 and then just subtract it from the total number of events, 36. So I'll just do this. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So I have 26 outcomes out of 36. I guess if you wanted to reduce that, 13 out of 18. But again, reducing isn't necessary always in statistics. The only time I think reducing is kind of necessary is to make it a little bit more reader friendly. So 13 out of 18 is sometimes easier to understand than 26 out of 36. A lot of times you'll see data, like if you're just watching a regular commercial, they'll say that it's 8 out of 10 did something. Well, 8 out of 10 is the same thing as 4 out of 5. So what impact are you trying to look? Letter D says probability of rolling a 6 on at least one of the die. 6 on at least. So could you roll a 6 on both die? At least one die, at least one of them is going to be a 6. So I'm going to take this entire column here, and I'm going to take this entire row here. Okay, so take a look how I have that drawn. Is there a number up there I could double count accidentally? What do you think? What, the 12. So be cautious. 12 happens in both the row and the column. Only count it once. So I have 6 that happen one way and 5 that happen the other. So that's going to give me an 11 out of 36 probability. So please note, don't double count that. Count it only a single time. So it doesn't matter if you put it in the row or the column to count it. It's just don't count it twice. But again, that could be an easy one that if you double counted it, and you're like, okay, if I double counted it, I would get 12 out of 36. Well, 12 out of 36 is still a number less than 1. So it could be easy to double count and not realize you made an error. Okay, let's change. Let's go to orange. How about orange? Letter E says probability of rolling an even on both. Okay, so an even on both. Even on both, even on both. Oh, I messed up. I'm sorry. I shouldn't have done that. Even on both. 2 and a 2. A 4 and a 4. A 6 and a 6. Okay, and even on both dice. Even number 2, 4, 6, 8. This is letter E. So I could also roll a 2 and a 4. I could roll a 2 and a 6. I could roll a 4 and a 2. And also a 4 and a 6. I could also roll a 2 and a 6. And I could roll a 4 and a 6. So even numbers are 2, 4, 6. So roll a 2 and a 2, a 2 and a 4, 2 and a 6, or a 2 and a 4, a 2 and a 2, a 2 and a 4, and 2 and a 6, or a 4 and a 6, a 4 and a 2, a 4 and a 4, so on and so forth. So the orange is 9 outcomes out of 36. And I guess you could say, well, I could make that 1/4, but again, not necessary to have. And then let's choose one more color. Let's go pink. I like pink. And F. Probability of rolling a number larger than 4 on both dice. Probability that I'm greater than 4 as my sum. So these are all the numbers that are bigger than 4. 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. I forgot one. Where's the one I forgot? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 3, 4, 5, 6, 7, 8, 9, 30. So I have a 30 out of 36 outcome. And again, if you wanted to reduce it, you can say, oh, that's 15 out of 18, which again would reduce to 5/6. So again, you don't have to reduce the fraction, you just go from there. Okay, so these are all pretty good events. Sometimes that sample space might be good to write, but I'm not going to grade if you have that written or not if it asks for it. Okay. All right. Problem number 4. You roll a 4-sided die. 4-sided die. And a 6-sided die. Ooh. You have a 4-sided die, which means you have numbers 1, 2, 3, and 4. And then you have a 6-sided die, which is this. And if you make your grid, and some of you are thinking, how do I have a 4-sided die? It's a pyramid, a 3-sided pyramid. Okay, so this is 2, 3, 4, 5, 3, 4, 5, 6, 4, 5, 6, 7, 5, 6, 7, 8, 6, 7, 8, 9, 7, 8, 9, and 10. Okay, so that's our sample. That's a 4. All right, so we can easily go through these. What is probability of rolling the sum of a 7? Probability of a 7. So there's 1, 2, 3, 4. I have 4 out of 24. Again, I could reduce it if I wanted to. I'm not going to worry about it. Letter C. What is probability of rolling a difference of 2? Difference of 2. Difference of 2. Help me out. Let's see. Let's see. I guess I could go 3 minus 1 and get 2. I could go 4. Let's see. 4. Difference of 2. So 3 minus 1 is 2. 4 minus 2. It says he has 6 outcomes. Help me out here. 3 minus 1. 3 minus 1 is 2. Only a difference of 2. What does that mean, my friends? What do you think? I'm stuck. Yeah.
Your first number that you roll would have to be greater than 1. So it would be like 3. You have to roll 3 first and then roll 1.
Okay.
So you have to roll 4 first and then roll 2 seconds to get it.
So 4 minus 2. I'm stuck. I'm still trying. I can't make it work in my head. Do you have a better clarification for me? Do you get 6 out of 36 or 6 out of 24?
I got 1 out of 24.
I-
I think it'd be more than that.
I agree with your 1 out of 24 because the difference of 2. So I'm getting the 3 minus 1 being 2. There's a difference of 2. So let's go. Let's see what else we'd have. 2 minus 2 is not going to work. 3 minus 1 is 2. 4 minus 1 is 3. Okay, 5 minus 1. 5 minus 1. 5 minus 2 is 3. Okay. 6 minus 4.
Well, isn't it saying that you roll your 4-sided die and then you roll the 6-sided one?
Let's see. Did it say?
Then I just redid it, and I got 5 out of 24. So if you roll the 4-sided one, you would actually get 3 out of 24. Because if you roll, you have to get 3 and then a 4. The only like number that would subtract down to 2 would be the 3, 4, and 5. And then it would have to be 3 minus 1,
3 minus.
3 then a 1.
Uh-huh.
And then it would be a 4 and 1 2. So 4 minus 2. That's one possibility. And then 5 minus 3.
5 minus 3.
Um,
Isn't it just like the second column? That would be 6 out of 24.
Second column.
Because 3 minus 1 is 2, 4 minus 2 is 2, 5 minus 3 is 2. And
So you're saying this is the column here?
yeah. And then it's,
Stirrup is stumped. I'm sorry. I can't get the answer that Mr. Anderson got. He claims, this is the claim, the answer is 6 out of 24. But I got big questions about it. I'll tell you what, if we came across that on a tester quiz, we're going to skip it. So I don't know. I have to ask him. I don't know how to do it. I can't do it. I think I'm broken. Yeah.
I think it was like, because you're rolling both the 4 and the 6, so like you can rearrange the numbers however you want. So like if you get a 6 and a 4 would be 2, and then if you get like so
Okay, so 6
yeah.
minus 4, that would give us 2.
And then if you get, and like this is like counting the 6 and dice first, so like the 6 and the 4 would be 2, the 5 and the 3 would be 2, the 4 and the 2 would be 2, and then the 3 and the 1 would be 2, so that's 4 outcomes. And then if you count the 4-sided dice first,
Uh-huh.
then it'd be the 4 minus 2 is 2, and then the 3 minus 1 is 2, and then you get 6. That's how I.
So I can't really use my grid to make it work. I have to.
Well, I mean, like I use mine. I put the. It might be easier because I put the 6 on the top, like go horizontal. I don't know if that makes a difference, but since then you roll both at the same time, so like you can look at both of them.
Okay. Okay.
Ways to just make the numbers work.
What I like is the answer is 6 out of 24 outcomes. And then you definitely get, I think you might be right. Wow. I mean, I can't dispute it. I think I like your answer. Okay. I'll go with that. Cool. Sorry, I stumbled. Letter D, the result of the 4-sided die. So the 4-sided die is greater than the 6-sided die. So again, I can't really look at my grid. So that could be a 4 and a 1, a 4 and a 2, and a 4 and a 3. I could do, and then my 4-sided die, I could go 3 minus 1 and 3 minus 2. And then I could go 4 minus 3. So that would work. So that's 6 outcomes. And where the first column here, this is our 4-sided die. So there's 6 out of 24 outcomes there. The only reason I could do that one is because of you guys being so smart and helping me through the last one. Cool. All right, use the sample space for the deck of cards provided in the reading. You select a single card at random, and it's a heart. Okay, so number 5. Probability that I get a heart. Make it red. Make the heart red because we're. Okay, so we have to know that I have 13 hearts in the deck out of 52. You can just keep it there. That's for A. For B, probability of getting a heart or a diamond. So a heart or a diamond, which are both red cards. So that's going to be 26 out of 52. And again, we're just drawing one card once we've shuffled. Letter C, probability of getting a king or queen or jack. Okay, there's 4 kings, there's 4 queens, there's 4 jacks. So that would mean there's 12 out of 52 outcomes there. Letter D, probability of getting a king and a queen. Oh. King and a queen. Again, we're only drawing one card. So is there a card that's both a king and a queen? No. So that's not going to happen. Letter E, probability of getting a king and a red. And this is where we will make errors. So let's take care of the reds first. There are 26 red cards in the deck. Of those 26 red cards, 2 of them are kings. So how many kings are left in the deck of cards? Or wait, I take it back. This is king and red. King and red. So how many red kings are there? 2. So I get 2 out of 52. Cool. Letter F. Probability of getting a black or a red. So it's one or the other. So all the cards, you have 26. You have 26 black cards. You have 26 red cards. We add these together. We get 52 out of 52. Okay, because if you took all the jokers out and all the other cards, made sure you just had the 52 in the deck, they're either black or red. So if you draw a card and you get a color that's not black or red, something's going on with that deck. And then letter G, probability of getting an ace or a diamond. Okay. Probability of getting an ace or a diamond. Okay, so a diamond, there's 13 of them in the deck. An ace or a diamond. So that means I have 2 other aces in the deck of cards. So that's going to just give me a 15 out of 52 chance. I don't want to count all 4 aces. I don't want to count the 2 diamond. Or wait. There's 3 more cards here. I'm sorry. 3 cards there. Because there's, of the diamonds, one of them's an ace. And then there's 3 other aces. So that means there's 16 out of 32. Or 16 out of 52 is a chance of getting that. Woo! Number 6. All right, you get a random lunch. You might want to get, your breads are rye, white. That's the bread. Your meats are ham, chicken, or turkey. And then you get American or Swiss for your cheeses. Okay, yeah, you could try and write out all the combinations, or you could realize that I have 2 outcomes here, 3 outcomes here, 2 here. Being that you have to use all 3 of the items. You have to have a bread, you have to have a meat, and you have to have a cheese, and you can't double up on anything. So 2 times 3 is 6. 6 times 2 is, I have 12 sandwiches that I could get out of this. And then, so that's for letter A. For letter B, what is the probability that the sandwich has rye bread but not ham? Okay? Rye bread but not ham. Okay, so I have rye bread, this and this, this and this. So I have 2, 2, and 1. 2 times 2 is 4. 4 times 1 is 1. So I have a 4 out of all 12 of my sandwiches. And then last but not least, number 7. There are 30 teams in the National Football League. That's wrong. There's actually 32, but let's just pretend it's years ago when we only had 30. The student argues that the probability that of any given team winning the Super Bowl is a 1 in 30 chance. Okay. So, are all NFL teams equal? No, we have some that we always know suck, right? Broncos just really sucked the past couple years. Obviously won a Super Bowl a couple years back. But not every team, if you were to go to Las Vegas or on one of the sports books, you can bet the futures. Now, right now, you can't bet the futures as of yet because the odds haven't been made. But after the Super Bowl takes place, sometime this summer, they're going to release the future bets on who wins the Super Bowl. Okay? There are some teams that are more likely in the eyes of the casino to win the Super Bowl than others. So they're not all NFL teams are likely. There's not, just because you start the NFL season and everyone's got their roster out, doesn't mean every team is equal. There are definitely some teams that are in rebuilding years that they're just they're looking for the future years later. Like we want to get the right lineups, so they're not all likely. All right, cool. Being that you're here, I'm giving you the points for that, and I'm looking at. So let me get a start on 4-2, but then we'll finish 4-2 on Tuesday. Sound like a deal? So I still got a couple minutes. All right. So I'm on page 88. All right. Page 88 in your books, 4.2. I'm only going to start this, but I'll have to stop. Okay. So they say that independence is a crucial concept in both probability and statistics and is introduced for the first time here. Yay. To calculate the probability of an event in which multiple outcomes must occur in sequence, we must know the probability of each outcome. If the events are independent, it's a straightforward process. So if you had somebody who was flipping a coin and they flipped a coin 3 times, the coin does not remember what it flipped last. Okay? So they're flipping the coin. I've seen guys at the craps table, like when you play the game of craps, and I know I keep talking about craps, but dice works really well in this situation. In order for you to roll the dice in craps, you have to toss the dice all the way across the table to hit the opposite wall, and then they land on the opposite side of the table. Okay? But I've seen guys where they'll take the dice and they will roll them right there in front of them on the table. And once they roll a 7 right in front of them, then they're going to roll the dice again because they think the dice remembered that the 7 came up. The dice don't remember what they rolled. Okay? So each roll of the dice or each flip of the coin are independent events. The event that happened the last time you did it does not have an effect on the next time you do it. Okay? So that's an important thing to know. So flip a coin, there's no effect on the associated roll of dice. If you want to talk about like the Avalanche and Nuggets to win their championships this year, the Avalanche winning the championship has no effect on the Nuggets. It's 2 completely different events. I mean, yes, it would be really cool if Denver could bust out and the Avalanche and the Nuggets could both win. You have, hockey and basketball. That'd be awesome. So independence can be a tricky concept, but if you calculate the probability of rolling 2 strikes in a row at bowling, maybe the first strike is indicative of the fact that you're bowling exceptionally well that day, thus increases the chance of a strike on the second roll. A particular matter is difficult to prove or disprove independence. The best way that we can normally do this is ask ourselves whether there's evidence that exists that the result that one event affects the probability of the next event. Okay? So if you were trying, in the game of bowling, the perfect game is a score of 300. Okay? So let's say you were to roll 3 strikes in a row. Psychologically, has your body changed a little bit to try and get the 4th strike and the 5th strike and the 6th strike? Yeah, there's a mental capacity that takes place. So there are things that are unrealized variables that we could consider. So in general, probability of both event A and event B occurring, if they're independent, is just you multiply the events together. So the probability of flipping a coin 3 times, you get 0.5 times 0.5 times 0.5, which is 0.125, which is a 12.5% chance that you throw 3 heads in a row. The example 2, the probability if you roll a die 5 times, obtaining all 6s is 1 out of 6 times 1 out of 6, basically 5 times if you're rolling 5 times, 1 out of 6 to the 5th power. If the probability of somebody who is a 78% free throw shooter would end up 3 straight successful free throws is 0.78 raised to the 3rd power. And then example 4, if there's an 80% chance of rain today in Denver and a 40% chance for rain in Dallas, the probability that both take place is 0.8 times 0.4, so you have a 32% chance that it'll rain in both cities. And I'm going to stop there. So I don't plan on having homework for you guys over the weekend. I know that I keep getting